In this video, we're going to look at disproving a theory or an idea using a counterexample, and we're going to look at this question, which was on your recent progress check. It was question number 10. So Jill says that if you multiply any two prime numbers together, the answer will always be an odd number. Now, I'm just going to do a bit of work here on the side, which is not working out that you would need to show for this question. I just want to show you why Jill might think this. So Jill probably knows some prime numbers like these ones. 7 is a prime number, 11 is a prime number, 5 is a prime number, 23 is a prime number. And if she takes a couple of these, if she takes 5 and 7 and multiplies them together, she gets 35. If she multiplies 5 by 11, she gets 55. If she multiplies 7 by 11, she gets 77. All of these are odd numbers. So you could see why Jill might think that whenever you multiply a couple of prime numbers together, that the answer will always be odd. But this question is asking us to prove that Jill is wrong. So they're already telling us Jill's wrong, and they want us to find a way to prove it. And the easiest way to prove it is to use the number 2, because 2 is a prime number, which is even. And if you multiply 2 by anything, you'll always get an even answer. So all you need to do for this question is to pick two prime numbers and multiply them together, but you've got to make sure that your prime numbers, when you multiply them together, do exactly what the question asked you to, which is to get something which isn't odd, i.e. in this case even. So did I pick two prime numbers? Yes, I did. Did I get an odd number? No, I didn't. Does that mean that I have proven that Jill is wrong? Yes, I have. So I'm very happy with myself. Okay. Now, Jill had been up the hill with her mate Jack. They weren't fetching pails of water though, they were focusing on prime numbers that day. And Jack said this, he said, if you multiply any two prime numbers together, the answer will always be a multiple of 3. Now, you've just seen me do a very similar question with even numbers. This time I want you to try it with multiples of 3. So pause the video and have a go. This is a we do question, and I will go through it in just a moment. Okay, hopefully you've attempted this question and you have an answer. So we want to prove that Jack is wrong. So we want to find a pair of prime numbers where when you multiply them together, the answer is not a multiple of 3. And again, you just have to do a similar thing to the last video, to the last page. You could use something like 3 times 11 to show that Jack is right, or 3 times 7. These are some of the reasons why Jack might think that this is true, but you don't need any of that for this question. This is just me showing you why Jack might think this. For this question, what you need to do is pick a pair of prime numbers where your answer is not a multiple of 3. So again, we had to pick two prime numbers, and I did. We were trying to show that it would be a multiple of 3, but we didn't get a multiple of 3. However, the question was asking us to show that Jack was wrong, and we've shown that Jack's wrong, because it doesn't happen in every case. We found a case where it doesn't work. Okay, so now it's time for you to have a go at some questions yourself. So here are 3 questions that I'd like you to have a go at. In each case, somebody has said a statement or a claim, and you need to try and show that they're wrong by giving one example that shows that they're wrong. So write down your 3 answers, and then you can go on to checking with your teacher whether you've got those right or not. So pause the video to attempt these questions. And I'm hoping that you've now attempted the questions and are ready to check with your teacher whether or not you've got these right.